Okie dokes. A girl wants to measure the height of a building from the bottom of the building to the top. She walks 20 meters and places a pole in the ground, uh, 3 meters vertically from the ground. So the pole is from the bottom of the building. She walks 20 meters and places a pole in the ground. Oh yeah. So 3 meters, a 3 meter pole. She then walks another 5 meters. She notices that from this point of view, on the ground, the top of the building and the top of the pole are in line. Calculate the height of the building. Now, I suppose what we're getting at here is that sometimes this question is done like this, where you'd get the height of the building and then add on the height of the girl, and you'll find that gets done a lot, like so, where you measure the angle. Okay, but in this case, we're going to argue that the girl lied down, like so, and lied down at ground level and looked up. And when she looked up, she found that the height of the building X and Y were in perfect alignment. Okay. What we can then do using this is we can use similar triangles. Now the whole exercise is using similar triangles to solve problems. Okay. So from this logic, we can say that we're basically saying, look, they're both the same angle. So this angle here. Sorry, I'll draw the big triangle and the small triangle for you first. So here's the big triangle, like so. Then we'll do the small triangle next. Triangle, whole thing, small triangle. And essentially, now the reason why these triangles are the same is because, well, first of all, they both have the same red angle here. These two angles are the same. Both of them are at 90 degrees, which means the blue angles are the same, and this therefore means the two green angles have to be the same as well. It has to add up to 180. These two triangles are in fact similar. What we're going to get here is 5 meters across, 3 meters up, and then we're going to add the 5 plus 20 to get 25. H. Now, what we see here is that the 3 corresponds to the H, and then what we say is how much bigger is 25 compared to 5. So we do 25 divided by 5 equals 5. So the large triangle is 5 times bigger than the small triangle. So then 3 multiplied by 5 is 15 meters. So the height of the calculate the height of the building, 15 meters, right? Next one. You're going to see that these questions start to repeat themselves a wee bit. So once again, I'm going to draw a big triangle. Follow up with a smaller triangle. My big triangle. Question. I'm going to do the small triangle. Here. Let's do a circle. There we go. I haven't even read the question yet, but I know we're using similar triangles because it's the name of the exercise. But we'll have a look, okay? Rope on a pair of stairs ladders are shown. Um, the rope on a pair of step ladders are shown stops the step from opening too far. Using similar triangles, find the length of the rope. So essentially, what we're looking for is we're looking for the length of this one here, which corresponds to the 80. Just remember that. Okay. So we're looking for the length of the rope, and it corresponds to 80. So I'll call this X, call this 80. And they're similar triangles because these two are parallel. The rope goes straight across and the ground goes straight across. It's 200 centimeters from here to here. So it's 200 centimeters for that angle there. And smaller one, it's 150. The 200 corresponds to 150. So we divide 200 by 150 and we get 4 over 3. This means the large triangle is 4 over 3 times bigger than the smaller triangle. We get what we're basically saying is to go the opposite way, you divide by 4 over 3. So it's going to be 80 divided by 4 over 3, because x has to be a smaller number, not a larger number. So it's going to be 80 divided by 4 over 3 equals 60. So x equals 60. Okay, you could do the opposite way around then, do 60 multiplied by 4 over 3 to make it bigger. That's where the small triangle turns into the big triangle. You can see that. Alright, that's handy enough. So that's 1 and 3 done. Next we're going to do is 5. Now, going to state some problems with 5 for a start, right? See the width of the bank? The width of the bank isn't the same all the way across. So that's why this is only an estimate. The width of the bank is not the same all the way across. And what we're looking to do is we're looking to find this out. Well, first thing I'm going to do is I'm going to use similar triangles. I'm going to make this large triangle here. Then we're going to make a smaller triangle here. Now, I'm not going to trace this out for once. I'm just going to do it just a bit more roughly sketched. Oh, and what we're going to say is that the smaller triangle has height 4 and length 8. They have a common angle, green angle. We're assuming both triangles have 90 degrees. So this means they're both similar. And then we have W here, 28 meters here, because 8 plus 20 is 28. What we're going to do is 28 divided by 8 is 3.5. So the large triangle is 3.5 times bigger than the small triangle. So what we're going to do then is we're going to multiply 4 multiplied by 3.5 equals W. And W equals 14 meters. And you're done. That's part 1. Part 2, explain why W is only an estimate. You could say that a bank and river may not be the same width. May not be the same size or width on every part of the river. And we see that's true. You can see that the W here is smaller than the W here. And we see that the bank isn't a straight line. You can see the blue coming in, so the bank isn't a straight line, okay? So it's not a perfect line. Now, find the value of point H in the following diagram at which the tennis ball must be hit so that it will just pass over the net 6 meters away from the base of the net. Okay, once again, we're going to use similar triangles. I think you must be, at this stage, you must be getting the gist of this whole question. That's 6. That's point 8. Then we draw the large triangle. These are the easiest chapters in the full book. You add the 15 and the 6 together to get 21. You get H. These are in fact similar triangles. So the 21, what I got from adding 15 and 6 together, it corresponds to 6. So to find out how much bigger the big triangle is compared to the small triangle, I'll divide 21 divided by 6. Pretty sure it's 3.5. We'll find out now. Yeah, it is 3.5. Okay, so it's 3.5. Okay, and then 3.5. So you multiply 0.8 multiplied by 3.5 will give you the H value, and then 3.5 multiplied by 0.8 is 2.8 meters. H equals 2.8 meters. Okay, That's the question 7 done. Now, question 9 is an interesting one. Let me explain how you do this. Now, we're going to make up our own figures. Now, once again, we're going to use similar triangles. I'm going to draw a line. Oop. I'm going to draw a line to represent the monastery. And we're going to assume that the monastery is on perfectly level ground. Okay, that's the assumption we're going to make. Now, similar to, it's very similar to question 1. We're basically going to do this trick here. Okay, so we're going to run through the exact same technique they did in question 1. Okay, so for argument's sake, so we're going to say, I'm just going to do a voiceover on it, but you guys can obviously write it down. The student starts at the base of the round tower, and what he does is he walks from the base of the round tower to a certain point. Oh, sorry. He starts at the base of the round tower. For argument's sake, he walks, let's say, 20 meters away from the. He walks 20 meters away from the base of the round tower. Sorry, you're actually going to have to use letters for this. So I'm wrong. You can't say 20, right? So what happened in the previous question, I'll run you through what happened here, right? What happened here was you start off at the base of the wall, and then from the bottom of the building, she walks 20 meters. Now, we don't know it's 20 meters, so we're just going to call it X meters, and places a pole in the ground, places a, it should be a 3-meter pole in the ground vertically. Okay, so it should be a 3-meter pole in the ground. However, we don't know the height of our pole, so we're just going to say Y meter pole in the ground. She then walks another, now we can't say 5 meters, we can just say another, use another letter, P meters. She notices that from this point on the ground, the top of the building, so the top of the monastery, and the top of the pole are in line. So that's how you do that. This is essentially how you do this question. I'm going to copy and paste this over here, and we're going to now do it in our own words. And send page. Change this because we're going to use the language of question 1 to do question 9. Okay. Steal a question from here. Alrighty. Now, so what we can say is smaller font, and measure sorry, you can't really measure, you can estimate height monastery by starting at the base of the monastery walking. Now we said here to here, so I'm going to keep doing this. The blue line, and we can call that X meters. Okay, so this blue line is X meters. as well. Good. Start base with a walk in X meters in a straight line by monastery. You can measure this using a trundle wheel. Then insert Y meter in the ground. Continue to walk until find point on the ground. Find a point with the head, with your head, ground level, top monastery, top of the pole, the top monastery, in line. Measure how much further you traveled, how much further you walked from the pole. How much further you walked from the pole to make this happen. Call distance P. Okay, so essentially what's going on here, guys, is that if you remember correctly, okay, so I'm just going to throw some numbers in here. This one's X. The distance from here to here is P. The height of your pole is Y. And the height of the monastery is H. You imagine what's going on here, where I basically, and what's the question want me to do again? Okay, how'd you get the height of the tower? Okay, just going to do two parts here. Okay, so imagine we knew all the numbers. Okay? So imagine, for argument's sake, X was 20 meters. P was 20 meters till you put the pole on the ground, an extra 5 meters until you found a position where it lined up, and the distance Y is a 3-meter pole. Okay. Now what we would have here is that this is 5 and this is 3. The distance of here all the way across would be 25. Okay, and what we did earlier was we said 25 divided by 5 equals 5, and we said that the big triangle is 5 times smaller than the small triangle. Then we said 3 multiplied by 5 is 15 meters. Okay, that's what we did in question 1. Now, here's what I'm arguing. Instead of these ones, here's what you're going to do. This one is size P. This one is P plus X, height H. And then what we said, this one here was height 3 plus height Y. And what we're basically saying is, you get P plus X divided by P. This tells you how much bigger the small triangle is, how much bigger the large triangle is compared to the small triangle. That was 25 divided by 5 in question 1. Okay, so that would have been 5. And then when you multiply that by Y equals height of monastery. I get that's a very difficult question to answer, but that's the way you gotta describe it. And then you can calculate that. Okay, and that's it. Now, Question 10. Pretty much the exact same question. Now, Jeff is 1.65 meters tall, so this is Jeff is 1.65. Casts a shadow of 0.7. Jeff measures the Eiffel Tower shadow to be 137. They're under the same sunshine, so the angles are the same because the shadows are cast at the same angles. The basically cast at the same angle as each other, so they're similar triangles. So what we do is we say these two correspond to each other. So we say 137.2, the Eiffel Tower shadow divided by Jeff's shadow. Yeah, 196. So the big triangle, the Eiffel Tower, is 196 times bigger than Jeff. So then when you can do 1.65 multiplied by 196, 1.5 multiplied by 196, and we get the Eiffel Tower 323.4 meters high. Alright, hopefully that makes sense. What does he know about the triangles? They're similar. How many times longer is the tower shadow compared to Jeff's? We found that out, didn't we? It was 190. How did Jeff deduce the tower's height? By multiplying his height by Jeff's height by 196 meters. Why did Jeff find the height of the Eiffel Tower to be? What did Jeff find the height of the Eiffel Tower using this method? He found it to be 104 meters. Which method produced the more accurate result? Reasoning. What two methods did he use? Uh, he did trigonometry. Oh, sorry, that was in chapter 16. That was long ago. Ask the question and don't worry about the last part. Now, finally, the group of students are trying to find distance between two trees on the opposite side of a bank using river pegs, measuring tape, and a large amount of string. They aligned the pegs in a particular way, taking several measurements and sketched a diagram A and B. A and B are the trees, C, D, and E are the pegs. In what way must the pegs and the trees be aligned if the student is to use the measurements to calculate AB? Alright, so essentially they're trying to use similar triangles. Use ABE, which is this one here. They're also trying to use ACD, which is the larger triangle. So the answer to question 1 is the pegs AEE must be in a line. EE and A, B, and C must. Peg C has to be in line with A and B when you're looking through peg C, and pegs D and E must be in line with peg A. Alright, calculate the distance between the trees. No bother. This is 57. A, E. This is A, C, D. So that's 57 and 133. Now, 57 and 133. You know this to be 48. This is tricky. They give us more measurements. Or do they? Calculate the distance between the trees. Alright, I think we may have it. I'm going to call this distance x. And this means this one's x, and this one over here will be x. We got them together. Okay, that's x plus 48, and this one is just x. Now I'm going to do 133 divided by 57 because these two sides correspond. It's going to be unusual. 133 divided by 57, 7 over 3. So the big triangle is 7 over 3 times bigger than the small triangle. So, in essence, x, when you multiply x divided by 7, multiply by 7 over 3, it results in an answer of x plus 48. And then what we can do here is cross multiply up to 3. So x times 7 is 7x over 3. But realistically, you can just set the 3 straight away. Multiply the 3 by x, and we're going to get x plus 144. Bring it over to your side, you're going to get 4x equals 144. And we're going to divide 144 divided by 4. X equals 36 meters. And that is your answer for the distance between the two trees. Go. Alright, done. Another group repeats the activity. They have similar diagram but different measurements. Their measurement for BE is 40. So they did BE of 40. Have a BC of 9. BC value is 9. And so instead of, sorry, and that's still called as X because we're not meant to know it. Based on the value of AB that the first group got, what measurement will the group have for CD? Alright, so I'm allowed to have this as 36. But I'm not allowed, I don't know what CD is. So the goal of the question is to find out what CD is. So what we're going to do is we're going to highlight CD. That's my goal. Find out what CD is. So what we have is, and we know that's 36. This is not too bad. That's 36. 36 plus 9 is 45. 45 corresponds to 36. Let's see here. 45 corresponds to 36, so that means that the big triangle is 45 over 36, which I believe is 5 over 4. 5 over 4 are 1.25 times bigger. So the big triangle is 1.25 times bigger than the small triangle. Then we do 40 multiplied by 1.25. We get an answer of 50 meters. Okay. Enough. Suggest how the group of students might ensure that BE was parallel to CD. How would they have ensured that BC was parallel to CD? Well, what I was trying to say is they could have said that they made sure that all the pegs were in alignment, as in peg C was in line with trees A and B, and peg A was in line with E and D. Another way of doing it, I suppose, was they could have. Try and think now. They didn't want to cross the river was one of the main reasons as well. So yeah, I suppose just make sure that the pegs are in alignment would be the main one in my opinion. I'm trying to figure this out now. Yeah, I'll just make sure the pegs are in line really. Alright.